Thank you. Okay, so let's gather all the information. Test the null hypothesis. Fortunately, null hypothesis and alternative hypothesis already given in this exam, in this or in this exercise. But most of the time, it will be not clearly mentioned. So you need to formulate it. So test the null hypothesis against the alternative hypothesis at the 5% level of significance. So the value of alpha is given. That is 5% means 0.005. So let's quickly see what are the information you have given. So this is the case of unknown sigma. So you have to think about T stats. For the known sigma, we generally use the Z stats. For the random sample size, n equal to 16. So n equal to 16. If n is 16, so what for the T stats we wanted to have degree of freedom di. So for n equal to 16, the degree of freedom will be 50. Right. Sample mean is given. So how to denote the sample mean? Sample mean is x bar, right? X bar is given. It how much? 110. Whereas the standard sample standard deviation, that is denoted by capital S, is given 18.18. And then alpha value is given. I'm trying to gather what are the information is given, and so that I can proceed, take the decision on how to proceed. So alpha value is 5%, so 0.05. These information are given, and along with that, hypothesis. So since it is already given, so we don't have to formulate it. So just go back and see the steps. Step 1, requirement. Does this sum or exercise meet the requirements? But it says the sample has to be random sample selection from the population. Yes. The question says that it is a random sample selection. The second one is the population. Either population has to be normally distributed or and has to be greater than 25. Although the value is 16. So check the another condition. The population is normally distributed. Is that is given in the sum? Yes, it is given the first sentence itself. The population is a normally distributed. So the requirement is fulfilled. Condition has met. What is the second step? State the null hypothesis and alternative hypothesis. Fortunately, in this sum, the null hypothesis and alternative hypothesis has been stated. So H0, null hypothesis is H0. It is given mu value. Mu is the mean. Remember the mu value. So mean of the population. So mu is 100. Alternative is mu is alternative HA. Mu is not equal to 100. So by saying this, can you think it is a one-tail or two-tail test? You have to take a decision, or you have to make a call over here. Do you think it is a one-tail test or two-tail test?
Two-tailed.
So since it is a not equal to, it means two-tail. We are not sure either the probability lies on the left side or the right side. If the situation, imagine the situation, mu greater than 100 or mu less than 100. These two could be one-tail test. But over here, it is clearly mentioned that the mean value is not 100. So clearly this is the case of two-tail. So while calculating, keep in mind, while calculating the p-value, we'll keep that one in mind. Is it one tail or two tail? So this is clearly the two-tail test. What is step number 3? Significance level. Okay. State the alpha value. Alpha value is already given 0.05. So 95% of 95% of confidence interval we have to test this claim. So alpha value is given. Step 4 is important here. That's why it carries more marks. In the case of sigma unknown, right? Sigma value is not given. So that means we have to apply T star. That indication over it. So the step number 4 is find the T stats. So T stats. What is the formula? X bar minus mu naught. Mu naught is same as mu over here. Divide by S capital N. What is X bar value? It is given the sample mean is 110 minus mu value, mu bar. So mu naught is, in this case, consider this one as a mu naught. So 100. Standard deviation is given 18.18. 18.18 divided by root square of n value. N is 16. So 16. Find out the value. 10 by 10 into, okay, 18.18 divided by 4. What is the T stats value? Find out. Find out the T stats value.
.2.
Okay, so what is the T stats value? Somebody said. Okay, let me go through the slides. Yes, 2 point. I think it's very clear, right? The T stats value is 2.20. Try to get it. It's easy sum, right? 10 into 4, 40 divided by 18.18. Yes, 2 points somewhere, right? So 2.30, yeah, exactly 2.2. Something will be there, but a rounding off will give you 2.20. Did you get this value? Others, could you confirm? Others, could you confirm? Did you get the 2.20? Please confirm this one. T starts 2.20. Did you get this?
Yeah, I got it. I got that as well.
Good. So what is the next step? That is very, very important. Determine the p-value. So the p-value, for this you need to see this table, this chart, which guides you. What it says that, this is the case of clearly we have mentioned in the step number 2, it's a two-tail test. So for two-tail test, what it says, for the two-tail test, it says that, is it the right side or left side? P-value is coming, so okay. Twice the area of the right to the test or twice the area to the left to the test statistics. So let's go through. What is p-value? In the case of two-tailed test, what will be the p-value? It says that twice, so 2 times to the right side of the area. So 2.20. So it will be, how much it will be? 4.4. Because of the decision rule, it should be the twice of the t value, t stats value. So the p value is Wait. The p value you should look at.
Wait, can we go back?
Yes, you check the t stats value for 2.20. Sorry.
Because the
Yes, go back to the t stats table. Let me open that one. T stats.
15.
Yes, you have to see there.
Zero 0.05. Isn't it 1.753?
T stat is 2.2. Use the p value 2.2. Just hang on. What is the degree of freedom now? 15. So the jet table on the 15, 2.2. Okay, this is important step. So let me take you to the jet score table. Okay, now the jet score table is there in front of you. Okay, and I'm drawing here through the annotation. Yes, the degree of freedom is 6 n equal to 16, so 15. So I'm going horizontally the 15 one, right? Let's see how much z stats. These are the z stat values. So how much is the z stat? It's coming around 2.2 something. So I think this one is more closer, 2.249. This step is important. And now you see the corresponding p value from here. Corresponding p value from the t stats we are getting 0.02. And using the decision rule, it is 2 times. So you will get the p value as a 0.04. Try to understand this one. This step is very, very important. Try to understand this one. How it came, the 0.02. At the t stats 2.2 with the degree of freedom 15, the probability value we got 0.02. I was drawing it on the t stats. So the corresponding probability value we got 0.02. And if you apply the rule, decision rule, it has to be 2 times the probability value. Why it is 2 times? Because I already shared this table to you, this chart to you. Yes. It says that in the case of two-tail, the p-value will be twice the area of the right to the test statistics. So it is a right or left, whatever. So it's a twice the area. So in that case, the p-value is coming 0.04. 2 times 0.02, so 0.04.
Wait, sir, sorry. So when you, after you find the t-stats, you have to look for the corresponding p-value
Using the t-stat, yes.
by looking at the line of your degree of freedom.
Yes.
Okay, got it, thanks.
Again, I can show you that one, how I got this one on the chat. Yes. I can show once again, because this step is very important. You need to understand how you are getting the p-value. Getting the p-value is really important. So in this case, we have the degree of freedom 15. Sample size is 16. So degree DF is 15. And we have to see, these are the t-stats values, right? T-statistics. So we need to match which is the closer one. So in the 15 row, if you move, our answer is not 2.1. It is close to 2.2. Since the 2.249 is closer compared to 2.131, which one will be more closer to our t-stats? The same one, 2.249, not the 2.6. So now we have to see the corresponding probability value. So the corresponding probability value we got 0.02. But since this is the case of two tail, we need to multiply by 2. If imagine is this could be a one tail test, either the higher or lower than, then we could have simply used the 0.02 instead of multiplying by 2. So that is the decision rule for the p-value, which is clearly stated in this figure. For the one tail or left tail or right tail, means the one tail, it's clearly the same area. The p-value will be same as the whatever the probability value on the t-stat. But in the case of only the two tail, we need to multiply by 2. That is the decision rule. We don't have to do anything. It is clearly stated that in order to calculate p-value, what is p-value? It's a probability value, a calculated probability. So that has to be 2 times the probability value which came. So with this one, the p-value came 0.04. What is next step? The next step is decision rule. Now,
Could you show us the whiteboard again?
yes, I'm showing. Okay, so this is decision rule. Yes. The next step is till here, no doubt. So I'm assuming that now moving to the step second. That is the decision rule. What it says: if p-value is less, h naught must go. So what is the p-value? 0.04. If p-value less than alpha, h naught reject. That is the rule, right? If p-value greater than alpha, not reject h naught, or h naught will not reject. So what is the p-value? We got 0.04. What is the alpha value? Remember here, what is alpha? 0.05, 5% confidence level. So 0.05, 0.05. So clearly this the 0.04 is less than 0.05. That means we should not reject the null hypothesis. Oh, sorry, alpha is, so what is the decision rule? If p is less than alpha, reject h naught. We are getting the p-value less than alpha? Yes, 0.04 is less than alpha, which was in the question, 0.05. So that means we need to reject the h naught. So what is the reject h naught?
Sir, sorry, excuse me. For the p-value, can you explain again why you multiplied 0.02 by 2?
Exactly. Okay. Go back here. I was repeating this one again and again. So yeah. Try to understand what it says. Go through one by one. Starting with what type of test it is. It is a right tail, left tail, or two tail. We mentioned here in the step second, it's a case of two tail because it's not.
Yes, I got that.
And if it is a two tail, it says that you need to multiply by 2, either the left tail or right tail. Whatever the probability value is coming, the total and the finally you have to multiply. So the p-value is twice the area of the right to the test statistics, or the twice the area of the left to the test statistics. So it is a positive probability. So just we have to multiply.
So if it was a negative probability, you'd multiply.
Yes, probably that won't be the case. So imagine like most of the time you just have to multiply by 2.
Okay, got it. Thank you.
But critical to go through the p-value. There are other ways to do this, but those alternative ways are more dependent on the Excel sheets. But since we have to do manually, so that's why we are facing these challenges. If you are supposed to do all these things using the Excel, then the Excel will give you the p-value directly. You don't have to play with all these things. But this is since we are doing it manually, so we need to follow that's why we have the 7 steps and we have to follow each and every. So come back here. It says clearly that p is less than alpha. Alpha is 0.5. So reject h naught. So that is the make a decision. Step number p-value, make a decision, and conclusion. Make a decision. Yes, we made a decision. Reject h naught. And then conclusion. What you have to write in a conclusion? Try it. I'm also writing. The first time I'm also writing. Try to make a conclusion in your own words. Do the mistake, but so in the conclusion, you have to write in the same way. Like the p-value is, I think it's more suitable here. So I'm writing it. The p-value is 0.04 less than 0.05. So you reject the null hypothesis. This is the first sentence, okay? Based on the exact what is the p-value is 0.04 is less than 0.05. So you reject the null hypothesis. That came in the step number 6. Reject H0. So this is the first sentence, and the second sentence will be you conclude that there is
Evidence.
sufficient. The word there is sufficient evidence.
Evidence.
There is sufficient evidence that the mean value, since we are not, what is, you reject the null hypothesis, we reject, okay. So what kind of conclusion you will make? There is a sufficient evidence that in favor of this one, the mean value is rejecting the null hypothesis not equal to, mean value is not equal to how much? 100. That's it. Maybe the grams and all, but in this question nothing is given. Are you getting the mean value of the population? Mean value, since we are trying to inference for the population, mean value of the population is not equal to 100, because that was the claim. The mean value is not equal to 100. That was the claim. We reject null hypothesis means mu value is not 100. So we reject this one, means alternative. We found actually the support for the alternative one. That's why we rejected the null hypothesis. H0, reject H0. H0 rejected means there is evidence for this claim that mean value is not equal to 100. So there is a sufficient evidence that the mean value of the population is yeah, I think so. Any doubt? Not equal to 100, because we got a claim for support for this claim. So there is a evidence, that is a claim that in the support, the mean value of the population is not equal to 100. Yes. Any doubt?
Excuse me?
Yeah.
Can you go over again step 7?
So the step 7, 2 sentences are important minimum. So the first one will be as per your stage number 6. The p-value is 0.04 less than 0.05. So you reject the null hypothesis. That is the first statement. Is that clear?
Yeah.
And since you are rejecting the H0, that means you found the support for alternative one. So what is alternative? Alternative means you found the claim or evidence for the mean value not equal to 100. So that is the same thing in the I'm writing in the sentence. So there is a sufficient evidence that the mean value of the population is not equal to 100. We are trying to generalize for the population, right? Population mean. This is important, not equal to 100. We got a support for this one. We got, because this one is rejected, so we got a support for this one. So that means we have evidence for this one. That means the mean value is not equal to 100. We got a support for that. So there is a sufficient evidence that mean value of the population is not equal to 100. Is that clear?
Yes.
Okay, we're doing more and more exercise will make you more clear. So probably you understood the importance of all the following all the 7 steps. Let's go through the second one. Probably now it will be easy for you to understand. Next exercise, number 6. In this one, the question itself, nothing is given. H0 and H1, you don't. It is not given. Let me share the same thing to you. Yes, exercise number 6. You need to formulate H0 and HA in this case. So I'm not erasing everything just because might be using the same thing again and again. Okay. Some of these things will. Here's the question. The Nelson Company is a global information media company and one of the following leading supplier of the media information. In the state of the media report, they announced that US mobile phone subscribers average 5.4 hours per month watch videos on their mobile phone. Something is given 5.4 hours per month. Do you think it is a proportion? No, it's a mean. Something average, it's given average. So think about it. It's a case of mean or like average. The population distribution is normal distribution. Think about the criteria. Is meeting the criteria, first criteria? Yes. The population distribution is normally distributed. Now, the sample size of 8 adults, N value is 8, was randomly selected from the target population. So again, this is the criteria is made, like randomly selected from the target population. It is clearly mentioned. It was found that the sample had a sample mean. See again, sample mean X bar is 7.16 hours. With a sample standard deviation 3.56. Nothing is about the population standard deviation. Sigma is not given, but sample standard deviation, capital S, is given. A claim was made, this is important, which will help you to formulate H0 and H1. A claim was made that the sample differed from the reported average of 5.4 hours. So what is the mu? Mu equal to 5.4 hours. So what is the claim? They're claiming mu is not equal to 5.4 hours. So it's a sample is differed from, it's not saying higher or lower than the average. It's saying differed. Differed means it's a one tail or two tail. Think about.
Two-tailed.
Pardon once again.
Two-tailed.
Exactly, it will be two-tailed because they're not indicating you the direction. We'll see some more exercise where clearly the mention it will be mentioned the direction. But fortunately or unfortunately, this is again the case as like the first one. It's like differed from the reported average of 5.4 hours. So we will test this claim at the 5% significance level and we'll see that is there support for this claim or not support for this claim. So just gather the information what is given. So let's see, n equal to how much? Quickly do it. N equal to 8 is given. So degree of freedom 7. X bar value is given for the sample. X bar is for the sample. So sample mean is 7.16. With the standard deviation of the sample, capital S is 3.56. Alpha value, we need to test this claim at the 5% significance level. That is the same as the previous one. So 0.05. I will switch to the whiteboard soon. Let me gather the information from here. Sigma is not given. So this is clearly the case of T-stats, and let me take you to the whiteboard now. So what I did, quickly I noted down all the information which was given in the sum in this exercise. What about the first requirement? We have seen while I was reading the question, it was clearly given the data sample has been taken from the target population at randomly. So that criteria is made and population is curve is normally distributed. It was given. Although the n size is less than 25, but still the other criteria was fulfilled. That means the first one is requirement made. Second one is important one, H naught or HA. So what is there?
The null hypothesis is that the mu is not 75.
So
And the
null hypothesis will be H naught. I'm writing here H naught semicolon mu value. Consider mu equal to 5.4 hours. So what will be the alternative one in this case? The claim. Alternative is your claim. The claim was made that the sample differed from the reported average of 5.4. This is the reported average, mu naught. So the alternative will be not equal. Differed means we are not sure is it in the lower or in the upper one. It is not mentioned in this case. So again, it will, the alternative will be mu naught not equal to reported one, that is 5.4 hours. And now you decide is a case of 1 tail or 2 tail. Since it is not equal to, this is clearly the case of 2 tail. 2 tails test. Why this condition is important? Because basis on this, we will find the p-value. Now, everything is given, find out the t-stats. What is X bar? 7.16. Are you able to see the board? Yes. What is X bar? 7.16 minus mu naught is given 5.4 divided by S. Capital S is given 3.56 divided by N. N is given 8. So root under 8. Could you find the t-stats for me? 7.16 into 5.40. Do it and just find out 5, 6, 1.6 and 6. 1.76. Right? 7 plus yes, 1.76 divided by 3.56. Root under 8 is 2.23 or something. Just find out. What is the value of t-stats you are getting? Let me know that.
1.398.
Others, did you get 1.398?
Yes.
For others who are struggling, although the answer is provided in this slide itself, at the bottom you could see, but idea is to work together. This time you do the mistakes, learn it and improve on your mistakes. So you will get the t-stats 1.398. Now, if you get this one, the next step is again very critical. We need to go back to the t-stats to see the p-value. Keeping in mind, this is the case of 210 test. Can you get the t-stat? Go back to your t-stats table and find out what is the degree of freedom? 7.
0.10.
Let others to do as well. So I'm also going through the p-value, like the t-stats. Okay. So over here, degree of freedom 7. So let me use some drawing. Let me do some. Okay. With the degree of freedom 7, please have a look on here on the screen. Degree of freedom is 7 because the sample size is 8. So in this horizontal line, let me see where I can go. How much is the t-stats? 1.398. Oh my God, 1.398. I think it's more closer to 1.415 rather than 1.895 or rather than 1.119. So 1.3 is 39 is almost it is 1.4. So that is more closer to this value 1.415. And now you go on the top, you will see the probability value 0.10. Did you get this number 0.10?
Yeah.
All of you? Those who are struggling, please ask.
Could I just see the whiteboard again, please?
Okay. Jumping to the whiteboard. Yes. Try to get the T stats value using the same formula we applied last time, last sum exercise.
0.4. 0.2.
So for the T value 1.398, we went back to the T stats table and we have seen that value, corresponding value, it comes 0.10. Let me do it once again. For the degree of freedom 7, for the sample size n, I was trying to draw like this. And since I found 1.415 is more closer to 1.398, and if you move corresponding up, we'll get the p-value 0.10. And this value is important for us. Since it is a two-tailed test, the p-value will be 2 times the probability value 0.10. That is 0.20. Now, very important, the decision rule. If p-value greater than alpha, then not reject H naught. So we know the decision rule. If p alpha value is less than alpha value, then reject the H naught. Else, if p value is greater than alpha, then not reject the H naught. So now you see in this case what happened. In this case, what happened actually? We got the p value. P value is how much? 0.20. And this value is greater than, what is the alpha value? The same as the last one, it was 0.05. So this is 5%, this is 20%. So clearly, it supports what? Not reject. So we have no evidence to reject H naught. In the previous question we have seen there were evidence to reject the H naught based on the p value. But over here we are not having a evidence to reject the null hypothesis because the p value is coming 0.20, 20%, far greater than 0.055%. So no reject H naught. We will not reject the H naught. Means we don't have the support for alternative now in this case. We are saying that this one is valid. So on the basis of this, what we will see is how to make the conclusion. So we write here the p value is 0.20 greater than alpha value 0.05. So you reject the null hypothesis? No, you should not reject the null hypothesis. So you will not reject null hypothesis. And then we can say that in the last case we have used there is a sufficient evidence. We'll say there is a insufficient. We use the word insufficient evidence. There is insufficient evidence that the mean value of the average value or the mean value of the population is not equal to 100. So there is an insufficient evidence that the mean value of the population is, or maybe you can say that there is a sufficient evidence that the mean value is equal to 100, or otherwise there is insufficient evidence that the mean value of the population is not equal to 100,
So,
not equal to 5.4. Insufficient for this one. So we can say insufficient evidence that mean value of the population is not equal to 5.4 hours.
so, sir, when you're making the conclusion, it doesn't matter from what perspective you're writing it, whether it's null or alternate hypothesis.
I think, yes, I think it doesn't matter. Even you can change it like this. There is a sufficient evidence that mean value of the population is equal to 5.4.
Yeah, because initially I put there is sufficient evidence that the mean
No,
value.
I think you can play. I got the point. Yes, while writing, because both makes the same sense, right?
Thank you.
Insufficient evidence regarding null hypothesis, or the sufficient evidence regarding the null hypothesis. Those both makes the similar sense. So it doesn't matter much. Either you can play with the sufficient or insufficient evidence. There's nothing as a golden rule.
All right.
So the conclusion is the p-value is greater than 0.05, so we will not reject the hypothesis.
Null hypothesis, H naught.
No.
We will not reject null hypothesis. That is important. H naught. Then next sentence, could you please go ahead?
There's insufficient evidence that the mean value is not equal to 5.4.
Exactly. Or otherwise, there is a sufficient evidence that the mean value is equal to 5.4. Both are same.
Okay.
Yes. That's what like we were discussing before. Both are sufficient, like both are correct. There is a sufficient evidence that the mean value is equal to 5.4. Otherwise, there is a insufficient evidence that the mean value is not equal to 5.4. Both are. Both are. If this one is clear, any doubt? We'll go through the next sum. Okay, exercise number 7. Go through the exercise, think about what is given, and maybe this sum is against, you will be familiar with this sum. If you recall, we have calculated the confidence interval for the similar sum. Confidence interval estimate we have done with the similar sum, sort of sum. So just go through that. Okay. From the earlier exercise of the example of the brain volumes, you know, the 10 data is given, the 10 different brain volumes is given. Over here also it is clearly mentioned that what are those numbers? 963, CMQ, 1027, so 10 data is given. And sample statistics is also given, means sample mean is given 1130 in the table at the down. Brain volume table is mean is 1130.20, whereas the standard deviation is 117.45. It is given, so sample statistics is given. And you need to assume that in this case that population is normally distributed. So this is just a fraction of the sum. So what is important here? A claim was made. So this is the case of hypothesis testing. The claim was made that population mean of the brain is less than 1100. This is important here. They're not asking that the population mean of the brain volume is differed from 1100. They are not saying that. They are saying clearly that it is less than. So if it is a less than or it is a higher than, it clearly indicates one direction, either the left or the right tail. So in this case, it is a less than. So it less than means left tail. So it is clearly a one tail case. The last two exercises we did, it was a two tail case. But this question, it is clearly mentioned in the claim that it is a one-tail test because the brain volume is less than 1100 centimeter cube. And we will test this claim at not 95. This time it is 1% significance level. So what is the alpha value here? Instead of 0.05, alpha value is 0.01. Do you think all the information is given to you in order to proceed, or is there anything which is not given? Just could you please make a comment on this?
I think everything is given.
Okay, so if everything is given, probably yes. So can we proceed like with the information? So I'm just trying to take the data from here, then I will switch to the whiteboard. So write on the paper, what is the n value? N is 10. 10 volumes is given, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So what is the freedom now? What is the value of X bar? The mean statistics, sample statistics mean is 1130.20. 1130.20. What is the mean standard deviation? It is given 117.45 from the table at the down. Okay. What is the alpha value? This time it is 1% significance level. So alpha is 0.01, not 0.05. Anything is given about the sigma, population standard deviation? No data. So this is not the case of, so this is the clearly the case of sigma unknown. In that case, we'll think about T statistics, running the T statistics. Okay. What is the next step? Assuming that all the condition requirement is fulfilled, because this is just a fraction of that bigger sum exercise. So assuming that it follows the normal distribution. Check for the, what is the step number 2? Formulate the H0 and HA. What is the claim? Claim is here, the brain volume is less than 1100. So I'm writing here the claim. So the claim is mu naught. This is important. Mu naught less than, they are saying 1100. That is the claim, right? Claim is that the population mean, that is mu naught is the population mean, we know that, of the brain volume is less than, important is, see the sign, less than 1100 centimeter cube. Okay, so let me take you to the whiteboard, sorry. So what is the alternative? The claim is the brain volume is less than 1100 centimeter cube. So since H0 is less than, what is your hypothesis? What is your null hypothesis? Could anyone tell?
Is equal to 110.
I think it's a yes. It's equal to 1100 centimeter cube. Null hypothesis is the plain one, the simple one. So alternative is it's not 1100, it's less than 1100. So the null hypothesis is the mean value is equal to 1100 centimeter cube. Okay. I think what is the alpha value? It is given 0.01. Is that clear? The alternative hypothesis and null hypothesis, is that clear to everyone? Over here I can write this is one tail test, not the two tail test. Previously we have written two tail test because it was not equal to, but over here it is less than or maybe the greater than one tail test. This helps while calculating the p-value.
So does that mean we won't multiply the p-value by 2?
Exactly. That's, if you're writing over here clearly, the chances are there you will not do the mistake over here in the step 5. Very good, thank you. That's why I'm writing. See, I'm trying to give you the clear indication that if you follow this one, the less chances will be there to perform any mistake. So clearly it is one test, so that time you don't have to multiply. It will be straight by whatever the p-value you will get from the t-stats table. Okay. Alpha value is 0.01. Can we do quickly get this one t-stats value? X bar is given. X bar is 1130.20. minus mu naught is 1100. Divide by capital is 117.45. Divide by square root of n value, n is 10. Can you get the t starts value with using this one? So it's 30.2 divided by 117.45 divided by root square root 10. Get the t starts value.
0.813.
Yeah, that's what I got as well.
0.8131 something.
Yeah.
I do get the same thing. I did get the same thing. So you will get the t starts value 0.8131. Others, please try to match this one. 0.8131.
Have the same.
So if you get the 0.8131, find out the p-value. So for the p-value, what is the degree of freedom? 9. So I'm going back to the table. Okay. So what is the degree of freedom? 9. So I'm doing some work here, some drawing here. Try to have those who understand the process can directly jump. Yes, degree of freedom 9 for n value 10. So if you just move horizontally and try to match the value t starts 0.8131. Keep that one in mind. 0.8131. What is happening here? 0.8131. I think which one is more closer? 88 or 70?
The 0.883. Yeah, that one.
Yes, because if you see the difference between 0.081 and 0.88 and the difference between 0.81 and 0.703, you will see that this number, the t-stats value, is more closer to 0.883. So we stopped here at 883 and then I will move and vertically up and see what is the probability value. So I'm rounding it out. It's 0.20. 0.20. Keep that one in the mind, 0.20, and go back to the decision rule. Because this is the different case, so decision rule over here. Yes. The decision rule, it says that if it is a one tail, either left tail or the right tail, the p-value is the exact the area of the right or the left of the t statistics. So in that case, we don't have to multiply by 2 if it is a left tail or right tail or it is a one tail. So clearly it is the case of one tail, which we have mentioned here. So can we write here what is the p-value? Point. How much we got? P-value?
0.02.
Right? So the p-value will be 1 into. Instead of writing 2, we'll write 1 into 0.20. That is 0.20. The same thing without multiplication. Got it? So again, now to go through the decision rule in the stage 6. P-value. Do you think what is the p-value? 0.20. And what is the alpha value? 0.01, 1%. So what do you think? The decision rule will be what? Clearly the p-value 0.20 is greater than alpha value 0.01. 0.01.
Excuse me.
So what is the case here? We will not reject the null hypothesis.
Excuse me.
Yes?
In the PowerPoint slide, when finding the p-value, it says that if it's a left tail test, we take the area to the left of the test statistic.
Okay.
So where are we taking?
So we are taking the same one without multiplying the probability value.
Isn't it supposed to be the one to the left?
Left and right, I think so. It won't be like meaningful over here. What it says that you just have to take the value, the probability value which you got it. At the degree of freedom 9, right? What it says that just go through here, match this value which is closer, go up and find this upper tail one. Just get this value. Upper tail probability. And just think about if it is a like two tail, just multiply with the 2. Otherwise, if it is one tail, just let it be the same one. As simple as.
Alright. So if the p-value was less than, then what does that mean we would do?
Okay, see, for the t statistics, you see on the top what is given. They are giving you this value.
Yeah, that's great.
Top part of this value.
Yeah.
So it's meaningless to understand like what is left and right, because the question is not like that. For the simple testing, hypothesis testing, we just have to take the value, the corresponding p-value. The question will be a bit different to have like more critical analysis. The question will be a bit different in terms of the interpretation of the left and right sort of probability value. So don't go in that much of depth. I will suggest you to just consider the p-value which you are getting over here.
Okay.
There could be a like different level of analysis, but over here it is limited for you at this time. In this course, it's limited. So keep in mind the corresponding p-value. Just keep in mind which this table is giving to you. There could be a different sort of interpretation and different more data and different analysis in order to interpret the left side and reason and the left side of reason. So what I'm suggesting you to just stick to the value which you got it here and just decide on the left tail and right tail. So in this case, it is clearly coming out 0.20 and 0.20 value is greater than 0.01. So in this case, the p-value is greater than 0.5, the alpha value. So it means we are not rejecting the null hypothesis. So we are not rejecting the null hypothesis. What it does mean? We are not rejecting the null hypothesis. Means we have not received any claim for the alternative one, that it is less than 1100. So how to write the final one? The p-value is p-value is 0.20,
Which is greater than
0.01. That is the critical value. You will not reject null hypothesis. No,
yeah.
null. So there is a sufficient, use the word sufficient, that will be more fine. There is a sufficient evidence that the mean value of the population is, instead of writing not equal to, just write equal to. So there is a sufficient evidence that the mean value of the population is equal to how much? 1100 centimeter. Else you can write there is insufficient evidence that the mean value of the population is not equal to 1100. Whatever you can choose, it's up to you. Clear?
Yeah, it's clear.
Okay, make it more clear because we'll do the same exercise with the Excel now. And we'll see that is there anything wrong in our calculation? Just we'll cross check with the Excel sheet. Can you open the Excel sheet now? We'll do the cross check with the sum. Is anything wrong or anything right? We'll see that. How Excel sheet gives different answer. Does it give different or the same one or more precise one? We'll see that one. So just open the Excel sheet. I'm also opening. Yes. Could you see one Excel sheet is in front of you? And all what I did, just I copied all the data. Can you do it in your system so that we can work together? This is a bit tricky because we are testing the t-stats. And the Excel is not providing you how to calculate the t-statistics for one single population mean. What I mean is, Could you type this all the 10 data in your system? 9631027. Can you do it fast? I wanted to do it at the same time. Okay, so you go to the data and the data analysis. Could you see the T stats at the bottom? You will see the T stats for paired 2 sample of means. The T stats for 2 sample assuming equal variance. T stats 2 sample unequal variance. That's it. The Excel is not providing you to analyze t-test for 1 sample. Is there any option for the 1 sample? Anyone? Are you able to see in your data analysis tools? Is there any option for the one sample t-stats?
No.
It won't be.
Yeah.
But there is a trick. There is a clever way of doing these things. So what we will do is, others, just next to this one, make it another one and put it 0, 0, 0. Because actually we are just trying to Excel that, to Excel that we have not 1, we have 2. But 2 is nothing. The second one is nothing. It's just a 0, 0, 0. And then in this case, we'll treat the t-stats for the unequal variance of the 2 means. So just, this is a tricky thing. That's why I did these things. This is the trick actually, to perform one test, one population mean t-test using the Excel. So do the 0, 0, 0 for the second group of sample. So the Excel will consider this one as a N1 sample and this is N2. But N2 is nothing like plain 0, nothing. But keep in mind, these 2 samples are unequal. Their variance are unequal, not equal. Now go back once again to the data analysis. Which option will choose out of 3?
T-test paired 2 sample for means. Or unequal, no. T-test 2 sample.
Yeah, it's not a paired one. We'll see in the higher stages on the hypothesis, we'll know that dependent one, independent one, paired one. So this is not a case of 2 samples which are paired, means one value is dependent on another one. So those are not the case.
Okay.
This is not a 2 sample with equal variance, because the another one we randomly select as a 0, 1. So
okay.
Just select the unequal variance. T states 2 sample assuming unequal variance. Click that option.
Where do we find the data analysis option?
Okay, go back here on the top. Over here on the top you have data. And then at the right extreme you have data analysis. Did you get that?
I'm just looking for it.
On the top, you see on the top you have a home, file, insert, formula, and then data. On the top, the different column name, file, home, insert. In your Excel sheet, if you...
Yeah, I think I just don't have the data analysis on the laptop, but I'll just keep listening.
Okay. But you could see easily this one, the data analysis is there. So what I suggest you to choose the t-test. Are you guys able to see my screen, right?
Yeah.
Okay, so what I'm selecting the third option, t-test 2 sample assuming unequal variance, then okay. And then the first set of data, I'm not taking the N1 and N2, which I have written on the, I'm not considering the level. So don't take the level 1. For value range second, I must provide the second one 0, 0, 0. Then they will be asking for hypothesized mean difference. This is important. If you will not provide, Excel will not give the right answer. What is the hypothesized mean difference? See the H0. What is the mu naught value? 1100 cm3. So you should provide how much? 1100. That is the hypothesized mean difference. In the level, by default, it will be 0.05. That is 5% significant level. But you need to change that by clicking this one. No, labels, you just not click the label. So don't take the label because we don't have selected the N1 and N2, which was the label. Alpha value, instead of 0.05, make it, this is the case of 99% or 1% alpha value. It was in the question. So 0.01 is the alpha value. For the output range, click here, and I wanted to have output in the same. So just any of the free cell, I gave this one. And then click OK. The result is in front of you. See on the top, the t-test 2 sample, assuming unequal variance. Yes, we assume we created a trick in the tricky way, and second sample with the 0, 1. So the variance are unequal. You see the variance is 0 for the second, mean is 0, and observation is 10. That doesn't matter. So what is important for here? We got the same. Did you get, like, did you see the match this with the sample statistics which I gave to you earlier? The mean value is same, 1130.2. Yes. What about the standard? So what they have given you for the variance is given 1113793. So variance is given. If you what you can do, just square root of the variance, you will get the, just see what was the square root of this value. Let's see, 117. Yes, standard deviation we have used in this sum is 117.45, the same thing. Hypothesized mean difference, we have taken into the consideration 1100, that appears here. Degree of DF, degree of freedom, 9 we have taken into the consideration. Now, can you check the manually what t value which we got? Is it the same t value which we get in the manually when we did manually? Just check.
Yes.
Yep.
Exactly the same, 0.8131, right? Okay. Now you have to decide. This was the case of what? P value for one tail or two tail? This case was of one tail or two tail? It was a one tail. So you don't have to take the any value for the two tail. So one tail P value, how much it is they're showing? 0.22. But in our case, how much the P value we got? 0.20. Yes.
Yeah.
This was our case. We got 0.2. But over here it's 0.21. Yes, the same one. So again, since if suppose you are doing the same sum on the Excel sheet and you got the P value, one tail is 0.2 or 0.21. Since this 0.21 is greater than alpha value, can we say this value 0.21 is greater than alpha value? Alpha value is 0.01. That means we should not reject null hypothesis. That means you need to take the final call as you should not reject null hypothesis. So Excel does provide the similar steps, which the way we did the manually. You see the Excel output. The same thing we got it there. So P value is 219. T statistics value we got the same 813 and DF. But in this exam, we are not giving you the Excel sheet. You have to do it manually. But keep in mind, there are ways to do it in the Excel sheet. So idea is, what is the conclusion? This sum. The overall conclusion is we should not reject null hypothesis because the P p-value 0.20 or 0.21 is greater than 0.01. So we should not reject the null hypothesis. I hope this is clear, right? Any doubt? Any doubt?
No, I understand.
Yeah, it's okay.
So I could see the time is 12:15 and maybe the allocated time for this class is like 10 to 12. So I will not go further. We have extra session for only those who has some doubt, struggling with some concepts and all. I will be here for another 2 hours for assisting them. But officially, it's better to close the class. And I want every one of you, if you have doubt, stay with us, with me over here for the next 2 hours. But I'm not going to take the classes. What is remaining here in this hypothesis testing? Let's go through once again. Okay, so the case 2, the next, maybe when we'll start the next time, we'll start with the case 2. That is the jet test for the single population mean. So still we are on the single population. We are dealing with the one samples or one population. So in this case, the second case Z is known and easy. The sum is very easy, it will be easy. So I will let you know this one next time. So just keep in mind what we have covered here. The t-test for a single population mean where standard deviation was unknown, is unknown. We have dealt with this one. I'm stopping the recording now, and just stay with me, and then we'll go through the doubt clearing session. Keep in mind, next Monday, before closing, yes, next Monday we don't have any quiz. So we will have the next quiz on next Monday. Meanwhile, I will get the much more time to communicate you in a better way to understand the hypothesis. So the last quiz will be totally dependent on the hypothesis testing.
But sir, we still have class on Friday, right?
Yes, we have the normal classes. So again, in the this Friday, we will cover the tutorial exercise, because some of the exercise was left, which we're talking about the hypothesis testing. So we'll have a kind of tutorial exercise. Then again, next Monday, 2 hours of the normal classes, where we'll have a like higher level of understanding, where we'll see the 2 and more population, or
Okay.
yes, this case is single one, but we'll see that dependent 1, 2 and more sample size. So we'll do the hypothesis testing by simply applying the formulas. We have the different formulas for that. So, and then again next week we have the 2 hours of tutorial. So I think enough time we have, like Friday 2 hours, Monday 2 hours, and again next Friday 2 hours. So 6 hours for the hypothesis testing. Much more steps you will understand, and with the various exercise, everything will be clear. Not a problem. So, and then you will sit for the quiz, and finally, and after the hypothesis testings, we have only one remaining chapter, that is regression, as per our outline, course outline. Did you go through the course outline time to time or not? It's better to, I will suggest you to see, are we guys like following the course outline which has provided to us? It's just for, let me see, yes, outline. Let me take you, it's important to see your progress as well in terms of where we are all together. So where is the course outline? Okay. I think the course content wise, we are on the hypothesis testing. So correlation and regression is remaining. And if you could see here, confidence interval, distribution, hypothesis testing. We have enough time allocated for the hypothesis testing. This topic is really important. That's why, like, we have 8 hours on the hypothesis testing, and that's why I'm taking you a bit slow. But anyway, don't worry. So only one thing is remaining, and like Another chapter is like correlation and regression altogether. And that chapter is really relatively easy, not much kind of rocket science. So try to give more emphasis on the hypothesis testings. We will have a quiz number 6 on the hypothesis testing. Based on the revision, I have, based on your feedback, I have revised the ANTEM exam. So it will be not much of in terms of, means there will be a proper balance of the difficulty level. I added the multiple MCQ as well in the final exam. So don't worry. 2 hours will be sufficient to make a sum or whatever it's not too many sums. So it will be relatively on average, it will be doable for most of you. Don't worry for that. Hope everything is clear. I'm closing this session. I'm closing this recording, and just stay with me for the